Well, there's always more to be done, but programmers are getting more sophisticated in their use of parallelization, at least for multiple cores. I think that the one area that I feel concerned about, which I think needs more development, is the use of vectorization. So there's actually multiple forms of parallelism in today's processors. There's the multiple cores, and there's also multiple SIMD lanes. And actually, the number of SIMD lanes is getting quite wide. So in the new, Sandy Bridge and Ivy Bridge processors, you're looking at AVX3, and they can do eight floating-point units, 8 floating-point operations in parallel, single precision, which is quite a lot. And a multiplicative factor of 8 is something you can't really overlook. So I think it's important for us to expose both vectorization and parallelization. Well, I've written a couple books, and one's about shaders, and the other one most recently is about parallel patterns. Now, the patterns book is a higher-level book about structured parallel programming. It does include information on how to use both Silk Plus and TEB to do vectorization and parallelization. More generally, I think that the thing to do is to look at the design of Silk Plus, because Silk Plus includes a lot of interesting concepts about how to do vectorization. Another project, actually two projects at Intel, which are available at What If, are the ISPC programming model and the ARBB programming model. And both of these look at how to express vectorization in a clean way. Well, it really is a C++ extension, and we're primarily now working on extending it to other compilers. So, for example, there's a branch GCC that now includes Silk Plus support, and we're looking at extending this to other compilers, and we're looking at route standardization of it. Other languages is an interesting question, and there are other ways to do parallelization in things like Java. But vectorization, I think, still needs more work in languages beyond C++. However, the reason we're focusing, actually Fortran is another good point. Silk Plus also supports Fortran. Now, and Fortran is important in the HPC space. The reason we focused on actually on Fortran and C++, is because why do you do parallelization? You do parallelization for higher performance. So we're focusing on the set of developers that actually care about performance. And those developers tend to use C++ and Fortran. Performance of Java and JavaScript, actually, are both increasing very greatly, and they are interesting targets for the future. There is also a project called Rivertrail from Intel, which looks at adding data parallel extensions to JavaScript. And that's especially interesting because those extensions then compile down to machine language, and the difference in performance between the Rivertrail code and the baseline JavaScript code is that much bigger. So you actually get a huge speed up compared to baseline code in JavaScript. Right, and the trick is that the expression of the desired parallelism in the source language has to be such that efficient code can be generated. And the Rivertrail project was looking at ways to express that in a JavaScript-friendly way that can still be compiled efficiently. And this is a Firefox plugin you can play with, and it does produce a quite good code. And actually, JavaScript performance has increased greatly because of a lot of effort put into it by the implementers of HTML5 runtimes. So, for example, in Chrome and in IE. So you actually are seeing some pretty significant performance to the extent that actually real-time games and such can be written in JavaScript. It isn't as performant as C++, but it is surprisingly performant.